Okay, we're going to do an introduction to Dijkstra's algorithm. So we're going to talk about what the algorithm is used for, and what sort of problems you could solve with the algorithm, how you will use the algorithm to solve the problems, so how we use it, and then we'll do a couple of examples on that, and then finally we're going to look at a harder example where there might be multiple start points and we want to use Dijkstra's algorithm on a network like that. So first of all, what is Dijkstra's algorithm used for? Well, it's used to find the shortest path through a network from one point to another, from one node to another. So let's say that I wanted to move through Hyde Park from point A to point J along this network of paths. And what I've put on the edges in yellow are values or weights for the edges, which might be the distance or the time it takes, or if I was talking about a network, which might be pipes or wires, it might be the capacity or how much information could flow through a wire or something like that. Okay, so it could be anything, these edges. So what I'm going to do is we'll get rid of the background image and we'll enlarge this so we can start doing Dijkstra's algorithm on it. So we'll make it quite big because we have to draw over the network. And what I'll do is I'll go through the algorithm and explain how you set out your working so that the examiner knows you've done the right thing and you get all the marks. So we said we were going to start at A and we try and finish at J, and we want the shortest path. So I'm going to write that up here. We're going to start at A and we're going to finish at J. Okay, so the first thing I'm going to do is the algorithm is going to be us going through the network and at each node trying to find the shortest distance from A. And then when we find the shortest distance from A, we're going to write it next to the node in a box. So firstly, we're going to start at A, and what's the shortest distance from A to A? Well, it's just 0 because we're already there. So I'll put a 0 at A, and it can't get any better than that, so I'm going to put a box around it. And the next thing I do is I'm going to mark the distances away from A at all the nodes that I can get to directly from A. So I can go from A to E, and that's 9 away. I can go from A to C, which is 4 away. I can go from A to B, which is 6 away. And then I'm going to put a box around the one that's smallest, and it's going to be C. Okay, so I put a box around 4 at C, because that's the best option. And I'm also going to put next to the box where I came from to get to C, and I came from A. And this is because when I found the path through the network, the shortest path, I might be asked to find out what the path is, what the order of nodes I've visited was. So now I've boxed the one at C, I look at all the nodes I can get to directly from C, and then I mark on the distance from A. So I can go from C to D, which is an extra 2, but it already took me 4 to get to C, so I can get to D in 6. So the distance to D is 6. That would be go from A to C to D. I can also get to G, which means adding another 3 on, which means I can get to G in 7. Put that there. And I can also get to B from C, which means adding a 1 onto 4, which means I can get to B in 5. Now, I already had 6 at B, but 5 is better, so I'm going to cross out the 6, okay, because I've done better than 6. Now, I've got to make sure that I cross it out and don't rub it out, because the examiner is checking that you've used Dijkstra's algorithm, which means that you must have got 6 earlier on, and you must now have crossed it out. So make sure you wrote down 6 and you just cross it out with a line, but make sure that you can still see that it was a 6 that you crossed out, but you've changed it to 5. Okay, and those are all the places I can get to directly from C, and I look through them and I pick the smallest. So I've got 9 at E, 6 at D, 7 at G, and 5 at B, and that's the smallest, so I'm going to put a box around it, and I'm going to mark where I came from. And I actually came from C, so I put C there. So we found that going A to C to B took 5, whereas going directly from A to B took 6, so A to C to B is a better choice. Okay. So now I've boxed at B, I'm going to look at all the places I can get to from B. Well, I've already boxed C, so I've just got to look at F, which is 2 more, so I can get to F in 7. So now I look at all the numbers I've got. I've got 9 at E, 6 at D, 7 at G, and 7 at F. So the smallest one is the one at D, so I'll put a box around it. And I mark down where I came from. I came from C. Okay. Look at all the places I can get to from D. Well, I can get to E. If I add 2 on, that means I can get to E in 8, which is better than 9, so I'll cross out the 9. And I can get to G in 3 more, which is 9. Now 9 isn't any better than 7, which I've already got there, so I'm not going to bother writing that down. Okay. 7's already better than 9. And that's it. So now I look through the numbers that I've got. I've got 8 at E, I've got 7 at G, and 7 at F. So the smallest is 7, and I'm just going to take my pick out of these. I'm going to pick the one at F, I'm going to box it, and I came from B. Let's put a little B next to it. I look at all the places I can get to from F. I can go F to G, which means add another 2 on. That gets me to G in 9, but I've already got to G in 7. I can go F to I, and add on 4, and that gets me to I in 11. Okay. And then I look through the numbers again, and I've got 8 at E, I've got 7 at G, and 11 at I, so I'm going to box one at G. And I mark down where I came from. I came from C. Let's put a little C next to it. Okay. And then I look at all the places I can get to from G. I can get to H by adding on 1, so I can get to H in 8, and that's the only one. Okay. So now I look through the numbers I've got. I've got 8 at E, 8 at H, and 11 at I. So I've got a choice of which one to do next, E or H. So I'm going to box E. And that was if I came from D. So A to E was 9, but A to C to D to E was only 8. So I came from D. Look at all the places I can get to from E. I can get to J in 12. And I can get to H in 11. But I could already get to H in 8, so I don't have to add it on. Okay. I'm now going to look at the numbers I've got left. I've got 12 at J, 8 at H, 11 at I. So H is the smallest one, so I box it. And I say that I came from G. I look at all the places I can get to from H. Well, I can get to J in 2, which means I can get to J in 10, which is better than 12, so I'll cross it out. And then I look at all the numbers I've got left, 10 and 11, and I box the smallest one, and the smallest one is the one at J, and that was coming from H. And as soon as the place you're trying to get to is boxed, you've finished, because that's the best you can do. Because if you look at I, it's already taken me 11 to get there, so it's only going to be more. So as soon as the place you're trying to get to is boxed, you're finished. So the shortest path now for this network has a total weight of 10. It means I can get from A to J in 10, whether it be 10 miles or 10 minutes or whatever the edges represent. And because I wrote down on the next to the boxes where I came from to get through the network, I can also write out the path. So we'll look at J, and I look at J. That's where I was trying to get to. I'm going to write this at the end. So J, and J came from H. So I put H before it, and I look at H. H came from G. So put a G before it. I look at G. G came from C. Put a C before it. I look at C, C came from A. And so that's the path through the network, A to C to G to H to J. So the path, the actual route through the network is A to C to G to H to J. Okay, so we're going to do example 2 now. So same thing, I want to get from A to H. So I'll do this one a little bit more quickly. I start at A. Sorry, let's just write down what we're doing. We're going from, we start at A, and we want to finish at H. Is it H? Yeah. Okay, so start at A, start 0 away from A, and box it. I look at all the places I can get to from A, so I can get to B in 9, and I can get to C in 11, and I look at the smallest one, which is this one, and I box it, and I say that I came from A. I put a little A next to it. And I look at all the places I can get to from B now. I can get to D if I add on 23, which is going to make it 32 total to D. And I can also add on 13 and get to E, which means that I get there in 22. Okay. Those are all the places I can get to directly from B. And I look through the numbers that I've got, 11, 22 and 32, and I box the smallest one, which is this one, and I say that I came from A to get there. And then I look at all the places I can get to from here. Well, I can get to E if I add on 9, which means I can get to E in 20, which means I can cross out the old one. I can get to F in 10, which means I can get to F in 21. And then again, those are the only places I can get to from C, and I look through them and I pick the smallest, which is this one, box it, and say where I came from C. I look at all the places I can get to from here, so I can add on 15 and get to G, which means I can get to G in 35, and that's it. That's the only place I can get to directly from there. I look through my numbers, and the smallest one is F, which is 21, and I came from C. I look to all the places I can get to from F. I can add on 10 and get to G, which means I get there in 31, which is better than this one. And I look through my numbers again, and the smallest one is 31, and that was from F. I look at all the places I can get to from there. I can add on 18 and get to H, which means that I get to H in 49. Okay. I then look at the numbers I've got. I've got 32 at D and 49 at H. So I box D, 32, and I came from B to get there. And if I add on 22, I can get to H. If I add on 22, I get 54, which is no better than 49. So 49 is the best, and it was coming from G. Okay. So now I can answer the questions. The shortest path is what's boxed, which is 49, and the route for the shortest path is, again, I write it out. I look at where I finish, which is H, and H says I came from G, and G says I came from F, and F says I came from C, and C says I came from A. So that's the route. Okay, finally we're going to look at this example where we have multiple start points, which means that I can choose on this network, for example, whether to start from A or B to get to H in the quickest time possible, or the shortest distance possible. So if I was having a race against someone, would I want to start from A or B? Which one could I get to H quicker? When you have multiple start points, you wouldn't know where to start. You wouldn't know where to start A or B. So the way to get around this problem is you do Dijkstra's in reverse. You start at the end. So although we want to start from A or B, we want to know which one's the best place to start from. And finish at H. we're going to do the algorithm starting at H and seeing which one we get to first, and that will be the shortest one. So what I'm going to do is start at H, and it's 0 from H, and I box it, and then I look at places I can get to from H. I can get to F in 6, E in 8, and G in 7, and the shortest one is 6, so I box it, and I came from H. Okay, then look at where I can get to from F, and I can get to C in 11, I can get to D in 10, and I look at all the numbers I've got now, and I pick the smallest one, and that's going to be 7 down here at G, and I came from H. So now I look at all the places I can get to from G, and that is D. I can add 2 on to 7, and now get to D in 9, so I cross out what I had before, and make sure you just cross it out, because on the exam mark scheme it will say give them a mark. For example, it would say give them a mark if they've got 10 crossed out at D, so you have to show it. And now I look through the numbers that I've got, and pick the smallest one, which is the one at E, and I box it, and that was from H as well. I look at the places I can get to from E, add on 2 to get to C in 10, which means I don't need that 11 anymore. And look at the numbers I've got. The smallest one is 9, and that was coming from G. So we look at the places I can get to from G, and it's just B, and I got there in 17. Okay. I look at the numbers that I've got, and the smallest one is 10, so I box it, and that was coming from E, and I mark all the places I can get to from C, and that's just A in 19, and I box the smallest one, and that was coming from D, and I can't get to anywhere from B, and so I box the smallest one, which is this one here, and that was coming from C. So now I can see that the H to B was the quickest route, which means that B to H was the quickest route. Okay, so let's just write this down. The shortest route was 17, and the route, remember we actually wanted to start from A or B, so the route was start at B, and it says from B go to D, and from D go to G, and from G go to H, and that's it. B to D to G to H is the quickest route.